Well, so last time we just finished up playing with the unit tests. All right, let's keep it quiet. We were playing with the unit tests very quickly. We have our friend class, and then we have our unit tests, which followed the same exact idea as in Python, just now we're doing it in Java with a slightly different framework. It's just a matter of ironing out the nuanced differences. So I can run them, and when all these tests pass, each test is very simple. It tests a single unit, where unit is like one piece of functionality. They all pass, and we're happy. And if one of them fails, well, not only will it tell us that, well, something's wrong with our code, but if one of those fails with well-named things, if I imagine for a moment the test equal friend objects are equal failed, well, now we know exactly where the issue is. It has something to do with equals. When they're equal, it's saying false for some funny reason. So the unit tests don't just let us know if our code's correct. It also guides us to where things might be incorrect, which is really good. Yes. So now on to data structures. And by the way, at this point in the course, if it hasn't dawned on you that everything we've been doing so far is effectively review, it's effectively review. All we've done is just, oh, hey, here's all the basic operations we use, variables, types, if statements, loops, but in Java, how to make your own classes, how to do unit testing. And this topic is about building a data structure, which is something we did in 161, but now we're doing it in Java. So it's still review. This is the last topic of the review stuff, but up until now, it's all review. All right, data structures. Like objects, I mean, data structures are objects, but we're making like a collection. We're making a data structure, something that is going to hold on to a lot of data for us. So it's not just this simple object like we had a friend, where it just stored like a first name, last name, and email address. This is going to be a little bit more sophisticated. What we want to do is make a collection, some data structure that holds on to several friends and does all the managing of our contacts for us. So we're going to do this with a class called the contact list. This is going to follow the same thing as it did in Python. The same general idea, just syntactic differences. Yeah. And do note that in the previous topic when we talked about the friend object, I often showed the difference between Python and Java. I'm not going to do that here. Now we're just into Java. So, with the friend class complete, there needs to be a way to keep track of several friend objects. So we're going to do this with a contact list class. So let's start. I'm going to go here, right click on the source, new Java, contact list, there. We're getting set. So I'm just going to change this view to be a little nicer. There. We've started our class. There's nothing in here. It's very boring, but it's started. The name of this class is contact list. So what fields do we want? If you remember back to the Python version, all we really used was a list. We had a list field. That's all we used. Well, here we're going to do something very similar. We're going to, instead of a list though, we're going to use an array. So we're going to use an array to keep track of our friends. But there's a bit of a conundrum, right? Let me scroll down here. For example, consider this general idea of what we want this class to look like. I want to have a contact list object that has some container to hold on to the several friend objects. Then we're going to use an array, and that is represented as an array of 1, 2, 3, 4, 5 empty spots. But the problem is, you remember back with lists in Python, a list could be empty, a list could have one thing in it, and so on. And a list, we could append forever to lists. The list would grow arbitrarily large. But arrays are different. When we make an array, we have to specify how big it is when we create it. And if I make an array of size 5 and I try to add a sixth thing, it's not going to work, is it? There's no more room. So we got to be a little more clever with how we're going to implement this. So the idea that we're going to have is we're going to start with an empty array of some size. Maybe it's size 10, 5, whatever. But there's nothing in it yet. It's like I have 5 open seats, but no one's sitting there. And those seats, 1, 2, 3, 4, 5, 6, 7. Let's do 7 because it's from there to the end. So I have an array of size 7. But I've got these 7 open seats that my friend objects can sit in. But as of now, how many friends are actually sitting in these seats? Tell me. 0. There's nothing there. So this is the idea. I'm going to make an array that starts empty, but it has to have a size. It has to have a capacity. And I'm also going to have a separate variable to keep track of how many friends are actually sitting in these seats. If I had 3 people sitting here, I would have 3 available spots, but 4 empty spots for additional friends. But the size would be 3. So we need to have a second field, size, to keep track of how many friends do we actually have in that array. In Python, when using a list, we didn't need this because we could just ask the list. If the list had one thing in it and we asked the list how big it would say 1. Right? The list didn't have that thing of these empty seats, right? Although it technically really does if you keep opening up the hood. But more on that later. So that's the strategy we're going to have. We're going to have 2 fields for our... We're going to have 2 fields for our contact list. One will be an array of friend objects, and the other will be just an integer, a boring old integer to keep track of the size. So we're going to start with that. Private friend array friends. Size. Great. Now, let's start writing a constructor. Public contact list. Now here's the thing. With the friend objects, the whole point of those friend objects were to basically just hold some data for us. And we passed the data to the constructor and the object, the instance, held on to that data. Here, this is a much more sophisticated... By the way, can you see this reasonably well back there, or should I... Is it getting washed out from the light? Let me lower the light one pitch.
It's a little washed out.
It's a little washed out? Let's see. Let's try that. Is that better at all?
Yeah.
Yeah? All right, good. Here, when we create a contact list, I mean, what do we really need to do to set it up? Let's take a moment and start writing this code, and then maybe we can piece together what we really need to add to this in order to create it. So let's say, bless you if that's what that was.
Yes, it was.
Size. When I create a new contact list with nothing in it, how many things are in it? That's not a trick question.
0.
0. All right, so size upon creation should be 0. I didn't need to pass size as a parameter or anything here. The next thing we're going to do is set friends equals a new friend array. But the problem here now is, what capacity should I make this array? How big should I make it? Anyone have an idea? 10. I love that idea. So there we go. 10. Great. Now, you're a programmer. You have no context for what this code is doing. And you see that line of code, friends equals new friend at size 10. And you're going to ask yourself, what the hell is 10? Why 10? What does that mean? Is 10 important? Does it have any significance? What does that mean? I mean, right now we're writing this code, and we know that a moment ago, we just decided 10 pretty arbitrarily. Kind of as like this default starting size, capacity. I gotta be careful to say capacity, not size, I guess. But that's not very meaningful. It's just some random number 10. So instead, any suggestions on what we could do to maybe improve the quality of this code a little bit?
Make it a variable.
Make it a variable? Even more precise, let's make it a constant. Right? Let's just make it a constant. So, the way we make a constant inside a class is often done like this. And if I go back here, I'm just going to copy this line. I'm going to copy these 2 lines. Let's start with just this one line of code. All right. Private, because it doesn't need to be public. It's just a constant that only really needs to exist inside this class. Static, because, well, this constant doesn't need to belong to any one individual instance of a contact list. It's just some information that the contact list class knows about. And whenever we want something that doesn't need to be associated with an instance of an object, we use that keyword static. If you're still not 100% clear on the whole static, don't worry too much right now. This is something that will make more sense the more you see it in the context of how it's used. But is there any questions about static right now? It means that this is a field, effectively. It means that it's a variable, not a field. A field is associated with an instance, like you have a first name, you have a first name, you have a first name, right? Those are the fields. This default capacity thing I've got going on there, it's not really a field, it's just some fact that we've decided on. So, static. Final, because it's a constant, shouldn't change. Int, well, it's an integer. And then the convention is uppercase, snake case. So now I go here and I go, default capacity. Great. Great. Now that's slightly more improved code because if a programmer comes along and they see friend equals new friend at default capacity, there's now no guesswork. There's no need to go, what the hell does 10 mean? They go, oh, just some default capacity. And if you care what that value is, you look at the constant. Chances are you don't really care what that value is because the value itself isn't important. It's just the fact that it's some default capacity that is important. Great. Now, here's the problem. Now, I will say, if I have this array of size 10, and I try to add that 11th thing, is that array going to fit that 11th thing in it? No. Now, I will say, spoiler, we're going to write some code to basically make it so that doesn't matter. It can just grow. But for the sake of argument right now, let's pretend it's not going to grow. And if I have a size 10, that means I can only ever have 10 friends. Maybe that's fine, but maybe I want to be able to have a way to specify how big that initial capacity should be. So here's what I'm going to do. I'm going to say public. I'm going to write another constructor. So now I have 2 constructors. We didn't do this in Python, but this is something we do in Java all the time. We have 2 constructors. What's important is that their signatures are different. The signature is like the name, the return type, which constructors don't have, and the parameter list. So it's important that we have different signatures. And yeah. There. And it's going to be the exact same thing, but instead of using the default capacity, I'm going to say, well, I want to be able to specify it upon creation as an argument that gets passed to the parameter initial capacity. That's what I want to do. Any questions about what we're seeing right here? Now's the time to ask if you have any question at all. So let's say, let me go back here. I'm going to get rid of this. This is the old friend playing code. I'm going to make a contact list. Here, let's just call this something entirely arbitrary. Okay? And let's make another one. Even though you're not really necessarily familiar with this, if I were to guess, let's call this, let me go back here for a moment. Let's call this one here the default constructor. It's a constructor that doesn't take any arguments. And then this one here is the not default constructor. Okay? This line of code right here, which constructor is it calling? This isn't a trick question.
Default version.
The default. How do you know?
It's got no parameters.
No parameters there. I'm going to be picky right now just so I want to be clear. This is something I mix up all the time. This is something programmers mix up all the time. There is a difference between the word argument and parameter. Okay? But they are used interchangeably all the time. Let's hit pause on that. Hit the next one. It'll be a little easier to explain. This line. Does that use the default constructor?
Nope.
No. Why? Well, because it took the value 100. And there's no more sophistication to it other than it just plays the matching game. This one took no parameters. So use the one that takes no parameters. This one took 1. Use the one that takes 1 integer. What do you think would happen if I do this? I mean, it'll spoil it pretty quickly. It's going to say, that's not a thing. There is no constructor that takes a double, so I can't do anything. Okay. Now, the difference between parameter and argument. This is the parameter, initial capacity. That's like the variable. The argument is the actual value passed to it. So there is a difference there, but I'm willing to bet you kind of see why people use those words interchangeably all the time because, well, whatever. So just FYI, there is a difference, but I'm going to mix them up. You're going to mix them up. Everyone mixes them up for better or worse. Great. So, any questions about what I just did here? I have 2 constructors. This is an example of overloading. Before we saw overriding. Overriding is when you had something like toString, and then you wrote your own to like override what you got for free. This is overloading. You have 2 methods with the exact same name. Here, these are constructors. But because their signatures are different, they will actually potentially behave a little differently. Right? So there you go. Yes?
What's the size equals 0 for?
Size equals 0. That is, how many friends do we actually currently have in that array? That's the idea of if I had 7 seats, I have an array of size 7, and I ask you, how many friends are actually in here right now? And there's no one actually sitting down. So that's what it is. It's to say upon creation, there's no friends there, so the number of friends, maybe a better name would be like number of friends. But size is pretty typical for a convention in terms of collections. But I'm glad you asked. Now, that is overloading. Now I'm going to show you something really cool that you don't really need to use, but I would recommend it. But it's got some funny syntax, perhaps. I'm going to show you something called constructor chaining. Look at those 2 constructors. They are identical with the exception of the fact that one used the default capacity and the other one took a parameter called, or has a parameter called initial capacity. Other than that, they're the same. Now, to use chaining, they don't technically need to be the same, but what we could do is this. Without me explaining what the hell I just did, does anyone want to take a stab at what I just did? I'll give you a second to look at that code, see if you can kind of guess. The change I made was on line 9. It used to look like this. Now it looks like this. Oh. Well, now it's correct because there's a semicolon. What do you think?
It called itself with the default capacity.
What it's saying is, okay, this is just another way to reference your own constructor if you call it like it's a method or a function. And I'm passing to that constructor a single integer that happens to be default capacity. So this basically, this first one here, this default one, kind of just delegates the work to the other one. You're a constructor that takes an integer. I'm a constructor that doesn't take an integer. If you call me, I just call you and give you the integer I want you to use, which happens to be default capacity. If you don't like this and you prefer it the way it was, that's fine. But I do recommend chaining because it's a little bit more robust against changes in code. Because then if you need to change it in one place, if you have two constructors, you might have to change it in two places. It's a whole thing. So there, that's constructor chaining. Kind of cool. There's also an aside in the course somewhere in here. There's an aside topic that kind of goes in a little bit more detail if you're interested. But that's basically what we have here. I'm not including the comments because I'm lazy. So I'm explaining it right now. But if you were to go download this code from the course website, it would include all the comments. All right. Any questions about any of this so far? Really, no questions? Yes.
Well, you'd still have to know how many friends that you were going to have initially, right? Because it's on the time when it's made. So
We're going to get to that because we have a little interesting, fun solution for that problem.
okay.
Yes.
Can you still do like this default capacity for the next one and do like this initial capacity or no?
Like the other way?
Yeah.
Well, let me see if I can make that make sense. No, I mean, I could, but it wouldn't work the way I would want it. Because if I call the constructor that takes an initial capacity, that means I want to make an array of size. Maybe I gave it 101. I want to make an array of size 101. But if the constructor that took one parameter were to call the default constructor, I would have no way to communicate to the I would have no way to make that array of the actual size I want, right? So the purpose of this constructor is to say make an array of this size. But if I don't do this and I just say call this, and let's pretend this is what it used to look like, it wouldn't matter what I passed to it. No matter what, it would always make it of the default capacity,
Okay.
right? Fun question though. Other questions? So I need to know, when I see no one asking questions, fine. Is it because we're all like, yeah, we're following along, we're fine, or is it because you're completely like, I have no idea what's happening anymore? Raise your hand if you're like, yeah, I'm pretty good. Raise your hand if you're like, I'm screwed. Be honest. All right, well, that's good. The problem is, you're in a room where half the people they don't want to raise their hand, but if someone else raised their hand, they would. I always have a laugh because this is what happens a lot. And this is not just true for this course, this is true for every course. Raise your hand if you're like first, second year. Yeah, okay, most of you. The number of times as a prof, I will stop in lecture and be like, okay, any questions at all? Honestly, ask. And crickets, nothing. Fine, great. Then after class, I'll have like 4 people ask the exact same question about the exact same thing that I paused and asked, does anyone have questions? Now, my point of me saying this is not to condemn you for not asking questions, it's fine. But I always think like, if you have a question, chances are there's like half a dozen other people in the room with the exact same question. So never be afraid to ask because chances are you're not the only one and someone's actually going to be really happy you asked. I don't know. I like getting questions. It's boring to just talk with people. But I'll keep going if everyone's good. You have a question? Just something? Testing. All right, so that's the setup. Notice 2 things, the imports. Okay, what do we have? These imports are going to become important later. The objects one we've already seen. The arrays one we'll see shortly. And no such element exception, that's the exception we're going to want to throw. We already know about exceptions, but we had to import something for it. But we'll see that shortly. So there's the imports, but the imports work same idea as in Python. There's two constants, but we actually only talked about one so far. We'll talk about the not found one in a moment. I'll just leave it out for now. You know what? No. Here. I am going to add this constant to the class, but I'm going to not explain it fully right now. It's a constant. Remember how when we would do a linear search, I would say, do a linear search for this value. And if you don't find it, return -1. Remember how I would always say that? That's what we call a sentinel value. It's a value that has special meaning. Now, if I see a function that says return -1, I go, what does -1 mean? If I see a function that says return not found, I go, oh, it's not found. So it's just a constant for a nice label. We'll see it used to hopefully make it make more sense. The two constants, the two fields, and the two constructors. Just explain the two constructors. It's called overloading, blah, blah, blah. The second constructor, yeah. Great. If I were to call contact list contacts equals new contact list 5. I'm going to go here, go back to my main, or just somewhere else in the code at least, and do this. And if I run this, if I ran this code, this is effectively what I have in my computer. I have a reference variable called contacts that references some contact list object. Within it are two fields. This one was called friend count. It was actually called size in my particular example, but same thing. And then friends is the reference to an array, because arrays are objects. So array variables are actually reference variables. So we have that array reference variable to an array that is of size 5, because I specified 5. That's what we have. This is what we have. I can't do anything with this object particularly interesting yet, but I'm prepped to start doing stuff. Now obviously, if this is supposed to keep track of my friends, I'm going to want a way to add things, maybe remove things, and various other functionality that might, give me a nice way to manage this information. So let's start with that. Now, this goes to the problem you just brought up. I have 5 friends. What happens if I add a 6th? I'm out of room. Okay. So we could go with that. We could just say, nope. If I ever try to add a 6th one, maybe this function just throws an exception or something saying like add capacity exception. Right? That could happen. But wouldn't it be nice if I wasn't bound by that capacity? Wouldn't it be nice if, even though I had an initial capacity of 5, I could add a 6th? Wouldn't that be nice? I think it would be nice. So we're going to do that. So, arrays have fixed size. The capacity of the array is not the same as the number of friends. Remember that. Capacity is the number of seats available. The size, or friend count, whatever you want to call it, is the number of people actually sitting in the seats. Since the arrays have fixed size, it's not possible to add any more objects beyond the capacity. It is not possible for me to go to this array right here. Now, I want to be very careful. This is the friends reference variable to an array. That's this. But it's a reference variable. This is the actual array. And the array, I can't make it bigger. If it's size 5, it will always be size 5. I cannot go to that array and say get bigger. Just be bigger. I can't. That won't work. It's not an option. But the friends reference variable can change what it's referencing. So you just laughed. What are you thinking?
You're just going to create a new array every time you want to add something?
Yeah. So the idea is, and we're going to go into detail, is, all right, we hit the capacity, and I want to add that 6th friend. Okay, well, secretly, behind the scenes, what we're going to do is just make a new, bigger array, copy them over, and then just have the friends reference variable not reference the old size 5 one, but reference the new one. Isn't that cool? We're going to hash this out much more as we go. So, here's the idea that I have an array, these orange people are my friends. Okay? Now, the reality is, I see people laughing. Don't laugh at my artwork. I think this is very well done. Look at them. They all have different facial expressions and everything. That person's indifferent, that person's surprised or something. That one's happy, that one's shocked or scared, and that one's very happy. So here's the idea. First of all, I want to emphasize, remember, friends are objects. And objects aren't stored in a variable. Objects are referenced by something. So when I say I have an array of friends, I don't really have an array of friends. Who wants to guess what I really have? I have an array of references to friends. So this is what it looks like. I have my friends variable that references an array, and the contents of that array are actually references to friends. So here's the idea. I come along and I want to add that 6th friend. You know what? Okay. I want to add that 6th friend. So what I'm going to do is just make a new array twice as big as the old one. Copy the reference variables over. And then just say, friends, don't reference the old, reference this one now. And we're good to go. But before I jump into this expanding the capacity thing, let's start writing add. Public. Now, when I add something, adding something to a collection is a side effect. And you might remember me saying, avoid mutability, avoid side effects. Those are your public enemy number 1 in programming. And that's right. When you make data structures, that's what they're all about. Mutability and side effects. It's about modifying the contents of the data structure. When you add something, you need to add, it needs to get added somewhere. It has a side effect. So really, when I add something, it doesn't need to return anything. It's not like a calculation where I'm saying, go calculate this, give me information back. Its return type could be void because it doesn't really need to do anything. So I'm going to start by writing void, but I'm going to change it momentarily. Public void add. It's going to take a friend. Okay? So this is the setup for my add function. Let's say I have no friends, and I want to add my first friend. So I'm going to say friends at index something. Which index? So let's say it's the first friend. What is size right now? What's the value of size? 0. Which index does the first friend go? 0, right? Okay. So the first friend would go index 0. This isn't correct at this page. I'm just kind of thinking out loud as I go. Equals the friend that I just passed to. So friends at index 0 equals the friend that I just passed to, right? Then I'm going to want to say, okay, but then size plus, right? Then increment size. Size was 0, now it's 1. So let's say I have one friend in it, and I want to add another friend. Which index does that friend go? What value is size right now? 1. And so which index does it go? This like second friend I'm adding? Index 1, right? So then the next friend would be index 1. It gets added, and then we increment size. And now size is 2. I want to add that third friend. Which index does that go in? 2. Wait a minute. What value did size have? 2. Huh. Interestingly enough, nope. We actually always add at index size as a consequence of zero-based indexing, which is nice. Size is 0. You can think of size as actually also so size is doing double duty. Size stores the value of how many friends are currently in there, while also storing the index of the next available spot. So I have 0 friends. We add a friend. Well, it goes to index 0. Increment size. The next available spot is index 1. So there you go. It's kind of nice. So size also plays double duty at the next available spot, the next available seat to add a friend. So I can actually just say friend at index size, increment size. We're good. We're good to go. I can now start adding friends. Let's do that. Add new friend. I'm just going to make a new friend right in here. Bob Smith. B. Smuth. I guess he got a typo when he made it. And I run this, and you know what? For the fun of it, here, before I continue, we're just going to jump down here and add one more method that we always really want in our collections, a very simple one called public int size. So now I want to be able to ask how many things are in there. We were going to add this way later in the topic, but let's add it here just so we can prove to ourselves that things are added. So s out contacts.size contacts.size. I'll just do it again. I'm going to hit run. Let's see what happens. What should we expect to see? Well, we should see size 0 and then 1 because we added Bob. And for the sake of, I'm going to do a debug so we can kind of see the state of the program at that breakpoint. If I go to contacts, we can actually see at index 1 we have the friend. In the contacts thing, in there's 2 fields, friends and size. Within friends is an array. That array at index 0 is this friend, and there's the details. So we can see that the friend was in fact added. Two, three, 4, 5. Let's run this. Not going to bother with the breakpoint. I'm going to hit run. So now I've added 5 friends, so it should say 0, 5, right? But then, of course, I do this. I go try to add the 6th friend, and let's see what happens. What's going to happen? Someone yell out, what's going to happen? Crash. I tried to say, friends at index 5, do something, but how many indices does that array have of size 5? How many? There's a total of 5 indexes, but what is the last actual index? 4, because we have 0, 1, 2, 3, 4. So I tried to add something at index 5. Index 5 out of bounds for length 5. Crap, we're screwed. So we've got an issue. Now, before I go on to fix this issue, we're going to change one thing about our code. Typically, methods like add and remove, depending, there could be some differences. Typically, they actually return a Boolean to indicate if it was successful or not. So this method will return true if it successfully added something, false otherwise. So what I could do here is I could check if there's enough room, and if there's not, I could just return false. Be like, nope, not happening. Not done. Can't do it. If it was successful, return true. So I could do something like if size is equal to friends.length, which is a way to get the capacity of that array. So if size is equal to the friend's length, maybe what I do is return false. There. I could do something like this. So now it gives me a way to be like, okay, true, yeah, it was added successfully, or false, no, couldn't do it, sorry, you're stuck. Now this program wouldn't crash, it just, let's see what happens. I run it, it won't crash, but this last add returned the Boolean false, we didn't do anything with it, but the size is still 5, because we couldn't add that 6th thing. But we're actually not even going to do it like this. We're going to do it a better way where we automatically do this expand capacity thing. And because of it, we actually don't have a case of having to return false. This method will always be successful the way we're going to write it. So it might seem a little foolish, but this method is going to return a Boolean, and it will only ever return false based on how we're going to write it. So that's why there's a return type Boolean, even though it's really only a side effect. Time I got. Perfect. So how are we going to deal with that situation? So first thing I want to do is, okay, if size, it's called the actual method, is equal to friends.length. What do I want to do if this happens? Well, we want to do this idea. Make a new array, twice as big as the original. It doesn't have to be twice as big, but the convention is to always make it twice as big, and there's some nice mathematical properties why we like that. Go through each of the things in the old one, copy them over to the new one, and then set friends to reference this thing. So here's what I'm going to do. I'm going to go over here, and I'm going to take this functionality out and put it in its own method. But it's going to be private. This method is going to be private because no one else should be able to use this expand capacity method. This is an internal method that's important for the functionality of the class itself, but should not be accessed or used elsewhere. So I'm making it private. Void. And this method is just going to be a nasty, filthy, side effect ridden method. So here's what we're going to do. New friend, oops. I'm going to make a friend array. New friends, because why not, equals a new friend array of size friends.length times 2. So this says make a new array of friends of the size of the original array times 2. Or, sorry, the current friends array size 2. So if it was 5, I'm going to make a new friends array with a capacity of 10. Next. Size. By the way, here I'm using the method size. I could easily just do this, which returns the field size, but the method just returns the field. But because sometimes it's nice to just use the actual methods, I'm doing it like that. If you don't like that, go ahead, just use the field. So for I from 0 to size, where, well, how many things are actually there? Really, this should also be equivalent to the length of the original array, because its capacity is full. I'm going to say new friends at index I equals friends at index I. I is 0. This goes to new friends at index 0. Goes to the current friends at index 0, takes the contents, copies it over. Index 1 copies it over. Index 2 copies it over. Index 3 copies it over. So on and so on and so on. And then after that, we say friends. Okay, you used to reference that array, that's this lineup right here. Don't reference that anymore. Reference that array over there. That's bigger with the stuff that we just copied over to. So now the field for the class friends, the field for the contact list class's field friends references a new array that we just copied the stuff over to that's bigger, which is fantastic. New friends. That's what this is. The first step was create this new array referenced by the variable new friends. Then the loop said, okay, copy you over, copy over, copy over, copy over, copy over, I'm done. Then we say, friends, you used to reference this? No, you reference this now. Any questions? I want to be clear, this is a very important thing to wrap your head around. Yes?
Why do we say like we make it double length instead of just +1?
We'll cover why we like it to be double in a few topics from now. We will talk about it. Really, we can make it times 10 if we wanted. But there's some mathematical reason why we like it to be double the size, but stay tuned. And I saw another hand here. Yes?
Since the old array isn't like directly referenced anymore, it's going to be, like deleted by the garbage collection, right?
Yes. Good. So the old array is not referenced anymore. So we have this array that is just floating there. And the garbage collector is going to come along and get rid of it. Throw it away. You might be thinking, well, hold on. What about all those friend objects? Those friend objects are fine. That array didn't store the friend object. It stored references to them. So imagine I'm pointing at you, and someone else point at her. Just someone. Help me out. Perfect. So I'm part of the old array. You're part of the new array. I get deleted. I disappear. But you're still referenced by that new array, so you're just fine. If we had forgotten to copy over the references to the data we cared about, those would get garbage collected too. But here we're safe because we did it the right way. Yes?
Why wouldn't we just make it like the capacity so it can hold more friend objects?
Initially,
Yeah.
we totally could do that. But there's always like, okay, what capacity would you pick?
Just one where you would never run out of space.
Well, give me a number. 100. Well, what happens if I want 101? I mean, we could play this game forever, right? So you're right. If we made a capacity big enough in the first place, we wouldn't need to expand capacity at least for a while. We would be able to do these ads 100 times without having to expand capacity. I thought, was there one more hand I saw? No. So here, we'll finish up the add thing. So the trick here is to do this. That's it. This will work perfectly now. If we ran out of room, expand capacity. This method doesn't even give a shit of how expand capacity did its thing. All that mattered is that it did its thing. If we ran out of room, we make it bigger. Make it bigger. We didn't really, we just made a new one that was bigger and copied it over. And then we carry on wherever size was. If we didn't have to expand capacity, whatever, we were fine. But the point is here, if I go back here, hit run, we will see this say 6 because it worked just fine. And if I do debug, we'll even see that contacts, this friends array is size 10, not 5 like it was originally. All right, we'll pick up here Friday.